Inequalities are normally solved just like equations are with red dudes. So take away 1 from both sides, divide both sides by 2, and if that was the symbol in the question, that'll be the symbol in the answer. That's the way it works most of the time, though there are some subtleties with that. But subtleties aside, what this video is telling you is that if you can see a squared expression in the inequality, you must not solve it with red dudes. You must instead graph the expression that is less than something, or that's greater than something. So here's a classic example. Okay, so to solve that, you graph this. Now, in other videos, I'll explain how to graph this quickly. For now, I'm just going to do it very fast without explanation. What I've done there is graph y equals x squared, and this one that connects the crosses is y equals x squared plus 1. So that's the correct one. That was just the working there. Okay, here's another example. I'm going to graph this by intercept. I know that it's a bucket shape, so like that or like that. So if I know where it hits the axes, I should be able to get that pretty accurate. So I'm going to do a little quick table. So when x is 0, so what I'm doing is I'm graphing this. If x equals 0, y equals 6. So it's got a y-intercept of 6. And if y equals 0, you get this. That's a quadratic. That's solved in a number of ways. The formula, completing the square, or factorization, which is what I do here. That makes it clear that for this to be 0, x could be 2 or 3. So it's got 2 x-intercepts, 2 and 3. So that's the graph. Okay, so that's the main thing, is that when you get a quadratic inequality, so when the highest power of x is a squared power, then you graph the expression and you ask, when is it higher than 0, or when is it less than 0? So when is this graph greater than 0? In other words, when is its height greater than 0? The answer is always. So the algebraic expression, the algebraic answer is all x. What about this one? When is that lower than or equal to 0? Well, what you do is you scan the x-axis. So is it lower than 0 there? No, it's way high, it's up there. So the answer is no, 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 no. This is where the graph is super high. This is a yes, because it's not just allowed to be less than 0, it's allowed to be on 0. All these are yeses because that graph is down low there. That's a yes as well, and then these are all no, no, no's. So the picture is this little stretch of ticks, and all these crosses are not part of the answer. The algebraic expression for that is just to use the mathematical version of the word between. And there it is. We're basically saying it's between 2 and 3 inclusive. I'll give you another example. Okay, so what I'm going to do is I'm going to graph that, and then I'm going to ask when is it less than 1. But I'm just going to save myself a bit of time by doing a red dude or subtracting 1 there. This is still the same question, but now I can graph that and ask when is it less than 0, which is usually easier for the eye to judge. So, graphing that. It's going to be a bucket shape, so I'm going to do this by intercepts. I'm graphing this now. So y equals negative x squared plus 4x. So if x equals 0, y equals 0. So So that's the y-intercept there. And if y equals 0, we now get this, which is a quadratic, which I'm going to solve by factorization. So x equals 0 or x equals 4. So the x-intercepts are 0, which you already knew about, and 4, which we didn't. Now, often the y-intercept helps me determine whether it's bucket up or bucket down. That doesn't help in this case because it could either be this or it could be that. One way to work that out is to look at the coefficient of the highest power of x. If the coefficient of the highest power of x is negative, then it means over to the right. It goes down rather than up. Or just imagine putting the number 10 in there. If you put the number 10 in there, you get negative 100 plus 40, which is negative 60. So you need to be pretty damn low when you're out here at x equals 10. So that's now as a bucket down situation. So when is that graph less than 0? So here. So yes. Is it less than 0 there? No, because it needs to be properly less than 0, not on 0. So it's no. Still no there at 4, then yes. So that's the picture answer. The algebra answer is x is less than 0 or x is greater than 4. And that's the solution to the inequality. Just do one final example. What's the graph for that? Well, in other videos you'll learn that that's a pretty quick graph to draw. It's just this. Doesn't need to be too accurate because we're basically asking when is that greater than 0 or equal to 0? Well, it's never greater than 0. At no point is this graph higher than the x-axis. But for one solitary point, it's equal to 0. It has a height of 0. So the answer to that is just x equals 0.